Well, this is a problem with circular motion and radial forces. So let's take a look at what's going on. So we have some kind of a circular turntable that's spinning around on an axis like this, and we have a small mass on the edge here. Let's see, we're told that the mass is, we don't know what the mass is. The radius of the turntable is 0.85 meters. The tangential acceleration is 0.11. Oh no, that's the angular acceleration. Alpha is 0.11 radians per second squared. And the coefficient of static friction is 0.66. We want to know how many revolutions does the turntable make before the mass begins to slide radially off the edge. Okay, so this is one of these problems where the force of static friction can be given as mu sub s times the normal force. It's at its maximum possible value because the mass is just about to slide off the edge. So let's identify the forces that are acting on this thing. You got the normal force and gravity pointing up and down. You got your centrifugal force, and you got your static friction holding this thing in place. All right, those are your forces. There's no tension, no applied force, no spring. That's it. So the sum of all my y forces is the normal force minus mg, which is equal to 0. And the sum of all my radial forces, we're using our standard sign convention, right? That out is positive and up is positive. So we have mv squared over r minus mu sub s times the normal force is equal to 0. Well, now I know that the normal force is just equal to mg from this top equation, so I can plug that in to my second equation. Now the mass cancels out. And I'm left with, I can solve for v because I know r, and I know mu sub s, and I know g, right? I get v squared, or v, is equal to the square root of mu sub s times g times r, which is 2.34 meters per second. So that's how fast, right? What I've done here is I've written a couple of force equations given the situation that this mass is just about to fly off the edge. Right, and I've solved for the only unknown I have, which is c. So when this thing is moving 2.34 meters per second, it's just about to fly off the edge. I guess I can convert that into an angular speed. Right, omega is equal to v over r, so that makes it 2.76 radians per second. And now it's just a matter of motion with constant angular acceleration. I know it starts at rest, has a final angular speed of 2.76 and an acceleration of 0.11. Using the equation that doesn't have time in it enables me to solve for delta theta. It gives me delta theta is equal to 34.6 radians. And I multiply by 1 rev over 2 pi radians to convert it into revolutions, and I get 5.5 revolutions. So that's how many revolutions it's gone when it reaches 2.34 meters per second, and it's just about to slide off.